always kind of always struggle with understanding logarithms, understanding, what they're trying to achieve and look at. All right. And that is just going to be, remember exponential form. Okay. So there's a certain tip that I'm going to have for you guys in this. All right. And the way that I always like to remember, and the way I always teach students, is let's create this simple equation. 2 to the third equals 8, right? We know 2 to the third power equals 8. Now let's go ahead and rewrite this in logarithmic form. Okay. The one important thing I need you to understand is the logarithm is going to have that base. It's the same base as your exponent. So I'm going to have a log base 2. Now again, in exponential form, this is going to be 2 of 8 is equal to 3. But here's what happens. When students look at a logarithm, they just kind of forget what exactly they're looking at. So I always tell students, if you get confused with the logarithm, if you don't remember where things need to go, rewrite it in exponential form. Log base 2 of 8, and they're like, what does that mean? Again, what they're asking is 2 raised to what power is equal to 8? And obviously you can see the answer is going to be 3, right? So if we just want to rewrite it in some general form, and then I'll kind of give you another concrete example. Like if I have log base b of x in exponential form, right? And these, you can work back and forth from there, is simply going to be b to the y power is equal to x. Okay, we're familiar with exponential power. I think that's more comfortable for a lot of students. So feel free, if you are working with something on logarithms and you need to rewrite it in exponential form, I don't have a problem with that on the side. Just make sure you're still continuing, working on whatever problem you have, and whatever you do, you transfer it back over. But let's go and look at an example where this could be powerful. So if I had a logarithm base 1/2 of the square root of 8, and I say, what is that equal to? Now, a lot of students are not going to be able to do this in their head, right? And even the rules of exponents might still, you could kind of rework this actually. And what the x? Oh, yeah. So you might be able to rework this using some rules of exponents that I taught in the previous tip. But let's go and look at it another way. If I had log 1/2 square root of 8, and I want to see, well, what is this equal to? Well, let's go ahead and use that as x. Now I can take this logarithm or this equation now in logarithmic form, and I can rewrite it in exponential form. So what I can say is, all right, 1/2 raised to the x power is equal to the square root of 8. Now I can apply these rules of exponents to go ahead and simplify this. And just like we talked about with the number one mistake, we want to look for that one-to-one property. We want to get the bases to be exactly the same, so therefore we can set power equal to power. So what I'm going to do is I'm going to rewrite a 1/2 as 2 to the negative first power. So that's going to be 2 to the negative x. I'm going to rewrite the square root of 8 as 8 to the 1/2 power. But I recognize I don't want to write, I need these to have the same base. So I recognize that 8 can be rewritten as a 2 cubed. So therefore this is 2 to the negative x equals a 2 cubed times 1/2. Again, rules of exponents, I can multiply these straight across, and I get a 2 to the negative x is equal to a 2 to the 3/2. And now, ladies and gentlemen, I can say negative x is equal to a 3/2, and therefore x equals a negative 3/2. So by going into evaluating this, I can now say the logarithm of 1/2 square root of 8 is equal to a negative 3/2, right? So a lot of times using this exponential form can help you not only understand logarithms and what you're trying to do, but it can also help you with evaluating as well as some solving.